September 27th, 1941, Portland, Oregon. The Star of Oregon, America's second Liberty ship, stood ready for launch at the Oregon Shipbuilding Corporation's brand new facility on the banks of the Columbia River. The vessel had taken 131 days to construct. Traditional maritime experts nodded approvingly. Given that Kaiser's crews consisted almost entirely of former farmers, housewives, and construction workers who had never seen a ship before, let alone built one, this timeline seemed respectable, impressive even. Yet Henry J. Kaiser, watching from the reviewing stand as champagne shattered against the hull, was already calculating something that would horrify every traditional shipbuilder in America. Not how to build ships faster, but how to build them continuously, without stopping, ever. Within 18 months, Kaiser's yards would be launching 3 complete Liberty ships every single day, not through faster construction. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Not through more workers per ship, but through a shift system so radical, so contrary to a century of maritime labor practice, that union leaders called it exploitative, medical experts called it dangerous, and traditional shipyard owners called it impossible. The mathematics were staggering. A single Liberty ship required approximately 350,000 man-hours of labor by mid-1943. At that rate, working a standard single 8-hour shift with weekends off, a shipyard could complete perhaps 1 vessel every 6 weeks. Even working 2 shifts, 6 days per week, construction still required a month per ship. German U-boats were sinking Allied merchant vessels faster than that. Britain was starving. The Battle of the Atlantic was being lost not through superior German naval tactics, but through simple arithmetic. The Allies needed ships faster than conventional shipyard operations could possibly produce them. Kaiser's answer emerged not from maritime tradition, but from his experience, building the Hoover Dam, the Bonneville Dam, the Grand Coulee Dam, massive construction projects where work never stopped, where crews rotated through round-the-clock schedules because concrete doesn't wait and rivers don't rest. In dam construction, continuous operation made perfect sense. Pouring concrete required uninterrupted work cycles. But ships? Traditional shipbuilders considered the comparison absurd. The Todd Shipyards Corporation, which had partnered with Kaiser on his first maritime contracts, examined his proposed labor schedule in early 1941 with undisguised contempt. Their confidential assessment, preserved in corporate archives, captured the maritime establishment's reaction. Kaiser proposes operating shipyards on a 24-hour, 7-day-per-week basis, with 3 rotating 8-hour shifts. This represents a fundamental misunderstanding of shipbuilding. Ships are not dams. They are not mass-produced objects rolling off assembly lines. Each vessel requires craft precision, coordination between specialized trades, and quality control impossible to maintain with constantly rotating crews who never see completed work. The proposal will result in chaos, accidents, and structurally deficient vessels. Vice Admiral Emory Land, chairman of the United States Maritime Commission, shared similar concerns. His private correspondence revealed deeper worries. Continuous shift work has never been attempted in American shipbuilding at this scale. The maritime unions will resist. The workers will rebel. Even if Kaiser can recruit enough labor, which seems unlikely, maintaining quality control across 3 shifts working different stages of the same ship presents insurmountable coordination challenges. Yet we are desperate. Britain loses 3.6 million tons of shipping annually. At current construction rates, we cannot replace losses. Kaiser's proposal may fail, but conventional approaches are already failing. The decision to approve Kaiser's continuous operation plan represented not confidence but mathematical necessity. If 3 ships per day was impossible, and conventional methods could produce only 1 ship every month, then defeat was certain. The gamble began in Richmond, California, where Kaiser's first shipyard rose from empty mudflats in the first months of 1941. The facility's layout betrayed its revolutionary purpose. Instead of single, massive building ways where one ship at a time would be constructed from keel to completion, Richmond featured 7 parallel ways, each designed to hold a ship in different stages of assembly. Railroad tracks crisscrossed the yard. Overhead cranes every 100 feet could lift entire prefabricated hull sections weighing up to 150 tons. The facility wasn't designed for traditional sequential ship construction. It was designed for something that had never been attempted. Parallel production across multiple shifts with ships at different completion stages moving through the yard like products on an assembly line. The workers who would make this system function began arriving in summer 1941. Kaiser's recruiters had fanned across America, advertising wages 20% above standard industrial rates and promising to train anyone willing to work. No experience necessary, the traditional shipbuilding labor force, recruited from established maritime communities where skills passed from father to son across generations, watched this influx with alarm. By August 1941, over 10,000 workers crowded into Richmond. Fewer than 200 had any previous maritime experience. They included farmers from Oklahoma, housewives from California, shopkeepers from Nevada, construction workers from Arizona. They included women who had never been allowed in shipyards. They included African Americans, who traditional yards had excluded. They included anyone who could hold a welding torch or read a blueprint. The International Brotherhood of Boilermakers, the dominant shipyard union, viewed this workforce with horror. These weren't craftsmen. They were laborers who would debase the trade, undermine wages, and produce inferior vessels. Kaiser's training program confirmed their worst fears. Traditional welders spent 4 years as apprentices learning comprehensive skills. Kaiser's instructors taught specific techniques for specific tasks in approximately 2 weeks. Workers didn't need to know how to weld everything. They only needed to know how to weld vertical seams on bulkheads or horizontal deck plates or curved hull sections, tasks they would repeat thousands of times. The shift system that would coordinate this massive unskilled workforce represented Kaiser's most radical departure from maritime tradition. The plan was devastatingly simple in concept, impossibly complex in execution. 3 complete shifts, 8 hours each, operating 24 hours per day, 7 days per week, with no shutdowns, no weekends, no holidays. Workers would be assigned to one of 3 shifts based on a rotation system that staggered days off to maintain continuous staffing levels. The first shift, called day shift, ran from 6 in the morning until 2 in the afternoon. The second shift, called swing shift, ran from 2 in the afternoon until 10 at night. The third shift, called graveyard shift, ran from 10 at night until 6 in the morning. Each shift employed approximately 1/3 of the total workforce. Workers stayed on their assigned shift for extended periods, unlike the rotating shift patterns common in other industries. This permanence had purpose. Kaiser's engineers had calculated that workers becoming thoroughly familiar with one time slot, one crew, one set of conditions, would achieve higher productivity than constantly rotating through different schedules. The mathematics underlying the shift system revealed Kaiser's revolutionary thinking. Traditional single-shift operations utilized facilities 8 hours per day. Double-shift operations, common in wartime factories, utilized facilities 16 hours per day. Kaiser's 3-shift system utilized facilities 24 hours per day. The productivity gain wasn't merely 50% more than double shifts, it was transformative. Equipment that sat idle 16 hours daily in traditional yards ran continuously. Cranes that would typically perform perhaps 30 lifts in an 8-hour shift performed 90 lifts across 3 shifts. Welding stations that might complete 20 seams per day completed 60. Every piece of equipment, every workstation, every building way operated at triple utilization. But equipment utilization told only part of the story. The real advantage emerged from work continuity. In traditional shipyards, when workers left at the end of their shift, partially completed work cooled overnight. Steel contracted as it cooled. Welds already completed created residual stresses as they solidified. When work resumed the next morning, New welds had to be made on cold metal that had already undergone thermal cycling. This start-stop pattern meant each day's work began afresh on metal in a different state than it ended. Kaiser's continuous operation eliminated thermal cycling. When day shift finished a weld at 2 p.m., the metal remained hot. Swing shift beginning at 2 p.m. continued welding on warm metal. Their work flowed seamlessly into what came before. When they finished at 10 p.m., graveyard shift continued on metal that had never fully cooled. The thermal advantage proved more significant than Kaiser's engineers initially recognized. Metallurgists examining completed hulls found that continuous welding produced more uniform metal structures than start-stop welding. The steel underwent one continuous thermal cycle rather than multiple interrupted cycles. Residual stresses distributed more evenly. Grain structures showed better uniformity. This wasn't planned. It was an emergent property of continuous operation that revealed itself only after sufficient ships were built and examined. Margaret Hill, who worked as a welder on swing shift at Richmond Yard No. 2, recalled the intensity of continuous production in interviews conducted decades later. You'd arrive at 2 p.m. and the ship you were working on would be warm, almost hot to touch. The day shift had just finished. Their welding equipment was still glowing. You'd pick up exactly where they stopped, reading their notes about which seams were complete. For 8 hours you'd weld continuously, same motion repeated thousands of times. When your shift ended at 10 p.m., you'd mark your notes for graveyard shift and leave. The work never stopped, it just changed hands. You knew that ship you were working on at 2 p.m. would be finished in 3 weeks, regardless of weather, holidays, anything. 3 weeks from keel to launch. That was the rhythm we worked to. The coordination challenges were staggering. When day shift finished work on a bulkhead section at 2 p.m., swing shift had to know exactly where to continue. When graveyard shift completed welding a deck plate at 6 a.m., day shift arriving minutes later had to understand instantly what remained. Traditional shipyards solved coordination through direct communication. Experienced foremen walked the yard. Craftsmen consulted with those who came before. Knowledge passed verbally. Kaiser couldn't rely on such methods. 3 shifts rotating through meant minimal overlap. Workers finishing at 2 p.m. rarely saw those arriving at 2 p.m. Those finishing at 10 p.m. never encountered those starting at 6 a.m. The solution emerged from Kaiser's assembly line philosophy. Ships weren't built as single integrated projects but as collections of discrete tasks. Each task had specifications. Each specification had completion criteria. Each workstation had documentation updated every 8 hours, showing precisely what was finished and what remained. The system required something unprecedented in shipbuilding: workers who could read, follow written instructions, and document their work for the next shift. Traditional maritime craftsmen worked through experience and observation. Kaiser's workers worked through written procedures. Bulkhead welding crews received instruction sheets detailing exactly which seams to weld, in which sequence, using which technique. The instructions included photographs showing completed work. Diagrams illustrated proper torch angles, acceptable bead patterns, correct penetration depths. Workers weren't expected to understand metallurgy or structural engineering. They only needed to follow documented procedures developed by engineers who did understand such principles. When their shift ended, they marked completion sheets, indicating precisely what they'd finished. The next shift, arriving 8 hours later, would read those sheets, examine the work, and continue without consultation or coordination beyond written documentation. This procedural approach horrified traditional shipbuilders. John Riley, chief naval architect for Bethlehem Steel Corporation, visited Richmond in September 1941. His inspection report captured the establishment's reaction. Kaiser has reduced shipbuilding to paint-by-numbers assembly. Workers follow written instructions like children following recipes. They possess no understanding of why specific procedures matter, no comprehension of structural principles, no appreciation for the craft they practice. This will produce vessels that look acceptable but contain hidden flaws. Ships built by people who don't understand ships cannot be trusted to carry cargo across oceans. Riley's prediction seemed validated in early 1942 when Kaiser's first Liberty ships began showing defects. Weld quality varied dramatically between shifts. Day shift produced consistently acceptable work. Swing shift produced adequate but occasionally problematic welds. Graveyard shift produced concerning failure rates. Inspectors found incomplete penetration, porosity, crack initiation points, not catastrophic flaws but concerning patterns suggesting inadequate quality control during night hours. Kaiser's response demonstrated his systematic approach to production problems. If graveyard shift produced inferior work, the system needed modification, not the workers needed blame. Engineers investigated the quality variations through February and March 1942. Their findings revealed multiple contributing factors. Lighting in the yards, adequate for day shift and marginal for swing shift, proved inadequate for graveyard shift. Workers welding at 3 a.m. simply couldn't see their work clearly enough to maintain standards. Fatigue affected all shifts, but impacted graveyard workers more severely. Human circadian rhythms make sustained alertness between midnight and 6 a.m. physiologically difficult. Even motivated workers struggled to maintain focus during these hours. Supervision quality varied across shifts. Day shift attracted the most experienced foremen. Swing shift had adequate supervision. Graveyard shift, the least desirable assignment, often received the least experienced supervisors. Poor lighting, physiological fatigue, and inadequate supervision combined to produce predictably inferior work. Kaiser's engineering team addressed each factor systematically. They installed massive lighting arrays across all yards, creating artificial daylight during night hours. The illumination levels during graveyard shift eventually exceeded natural daylight, eliminating visibility as an excuse for poor work. To address fatigue, Kaiser implemented mandatory break schedules. Every 2 hours, graveyard shift workers received 15-minute rest periods. Not suggestions, requirements. Foremen enforced breaks because fatigued workers made mistakes that required expensive rework. The break system reduced productivity per worker hour, but increased overall output by reducing errors. To address supervision quality, Kaiser created premium pay incentives for experienced foremen willing to work graveyard shift. The differential was substantial, 25% above base pay. This attracted qualified supervisors who previously avoided night work. The quality improvements appeared within weeks. By May 1942, graveyard shift defect rates had fallen to levels comparable with day shift. The systematic approach to quality control revealed a crucial insight. Continuous operation didn't inherently produce inferior work. It produced inferior work when systems weren't designed to support continuous operation. Once lighting, brakes, and supervision were optimized for 24-hour schedules, quality became consistent regardless of time. Critics claimed this approach would fail. Ships were too complex. Construction required too much tacit knowledge, too much coordination, too much communication between trades. Written procedures couldn't capture the subtle judgments experienced shipbuilders made constantly. They were correct that traditional shipbuilding required such judgment. Kaiser's innovation was eliminating the need for judgment by simplifying and standardizing every operation. The results emerged slowly through late 1941 and early 1942. Kaiser's first Liberty ship required 197 days from keel laying to delivery. Ship number 2 required 169 days, ship number 5 required 128 days, ship number 10 required 97 days. Each successive vessel took less time not because workers got faster, but because Kaiser's engineers continuously refined the procedures. Welding sequences that initially required coordination were redesigned for independent execution. Tasks initially requiring multiple trades were redesigned for single trade completion. Operations initially requiring experienced oversight were redesigned with written checklists that any literate worker could follow. By spring 1942, Richmond was completing Liberty ships in an average of 70 days. 3 shifts working independently on different vessels simultaneously. The production rate had doubled not through faster work but through continuous operation. Then something unexpected occurred. The continuous shift system revealed an advantage Kaiser's engineers hadn't anticipated. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Traditional single-shift or double-shift operations experienced significant downtime. When workers left for the day, equipment sat idle, materials waited, partially completed work cooled, contracted, sometimes warped. Kaiser's three-shift operation eliminated virtually all downtime. Welding equipment stayed hot, materials moved continuously, partially completed sections never cooled completely, maintaining more consistent temperatures and reducing thermal stress in the metal. The coordination between shifts, initially considered the system's greatest weakness, became its strength. Day shift welders finishing at 2 p.m. would leave partially completed seams at specific stopping points designed by Kaiser's metallurgists to minimize stress concentration. Swing shift welders arriving at 2 p.m. would continue from those exact points, their work beginning before the previous welds fully cooled. Graveyard shift would complete the sequences. The result was more consistent weld quality than traditional methods produced. By summer 1942, Kaiser's continuous shift system was completing Liberty ships in 42 days on average, 3 vessels launching every single day from Richmond's 7 building ways. Admiral Land, who had authorized the experiment with deep skepticism, visited Richmond in July 1942. His tour of the facility left him shaken, not by chaos or poor quality, but by the clockwork precision of 3 independent shifts producing ships faster than traditional yards could believe possible. His report to President Franklin Roosevelt captured the transformation. The Richmond operation represents a revolution in maritime construction. 3 shifts, totaling over 25,000 workers, operate with coordination rivaling the finest traditional yards, despite minimal experience and constant personnel rotation. Ships move through 7 building ways in sequence like automobiles through assembly plants. Quality inspections reveal vessels meeting or exceeding specifications. Construction time has dropped to 6 weeks and continues falling. If Kaiser can scale this approach across additional yards, American merchant ship production could exceed all other nations combined. The scaling began immediately. By October 1942, Kaiser operated 7 major shipyards, 4 in Richmond, California, 3 in the Pacific Northwest along the Columbia River. All employed the 3-shift continuous operation system. Total workforce exceeded 90,000 by December 1942, all working the same relentless schedule: 8 hours on, 16 hours off, 7 days per week, no holidays, no shutdowns, no exceptions. The human cost of this system began emerging almost immediately. Medical facilities at Kaiser Shipyards reported alarming patterns. Workers on graveyard shift experienced significantly higher accident rates, exhaustion, disorientation, impaired judgment from disrupted sleep cycles. Swing shift workers reported family disruption, arriving home at 10:30 p.m., sleeping until 6 a.m., spending mornings managing household affairs before returning to work at 2 p.m. Day shift workers, with the most conventional schedule, still worked weekends, holidays, and 70-plus hours per week without breaks. Traditional labor practices provided rest days. Union contracts guaranteed time off. Kaiser's continuous system eliminated both in service of production. Workers who complained were told Britain was starving, ships were desperately needed, personal convenience was secondary to national survival. The International Brotherhood of Boilermakers filed formal complaints with the National Labor Relations Board in November 1942. The union's position was clear. Continuous operation with mandatory 7-day workweeks represents exploitation regardless of wages paid. Workers have right to rest, to family time, to religious observation, to basic human dignity. Kaiser treats labor as interchangeable machine components to be used until exhausted and replaced. This violates fundamental principles of workers' rights. The National War Labor Board, created to mediate wartime labor disputes, examined the case with acute awareness of competing pressures: workers' rights versus war production, Human Welfare versus Military Necessity. Their ruling, issued in January 1943, acknowledged the exploitation while permitting it to continue. The three-shift continuous operation system at Kaiser Shipyards imposes significant burdens on workers. Extended work weeks without rest days, disrupted family schedules, and health risks from sustained shift work represent legitimate grievances. However, military necessity requires merchant ship production at maximum sustainable rates. The board finds that while Kaiser's labor practices would be unacceptable in peacetime, wartime emergency justifies temporary suspension of standard protections. This ruling shall remain in effect only for the duration of hostilities and shall not establish precedent for peacetime labor relations. Workers accepted this ruling not because they agreed but because they believed the rationale. Ships were needed. Men were dying overseas. Personal sacrifice seemed reasonable when measured against the stakes. Yet, the psychological toll accumulated regardless of justification. Sleep deprivation became endemic. Workers on graveyard shift reported profound disorientation. The human body's circadian rhythm, evolved over millions of years to follow day-night cycles, cannot adjust to permanent night work. Graveyard shift workers experienced constant fatigue, impaired cognitive function, and significantly higher rates of depression. Swing shift workers faced different challenges. Arriving at work at 2 p.m. and finishing at 10 p.m. meant their waking hours aligned with neither day workers nor night workers. They existed in temporal isolation. Social activities happened without them. Family dinners occurred during work hours. Their children were asleep when they arrived home. They were asleep when children left for school. Day shift workers, despite working the most conventional hours, faced their own burdens. Working 7 days per week meant no weekends, no regular family time, no religious services, no community participation. Life reduced to work and sleep with minimal space between. The childcare crisis emerged as one of the continuous shift system's most acute challenges. Traditional shipyard work, conducted by men during standard daytime hours, required no childcare arrangements. Kaiser's system, operating 24 hours with 30% female workforce, created unprecedented demand. Mothers working day shift needed care from 6 a.m. to 2 p.m. Mothers working swing shift needed care from 2 p.m. to 10 p.m. Mothers working graveyard shift needed care from 10 p.m. to 6 a.m. No existing childcare system operated on such schedules. Kaiser's solution demonstrated his approach to production problems. If childcare facilities didn't exist, build them. In early 1943, Kaiser opened 2 massive childcare centers adjacent to Oregon Shipbuilding and Swan Island facilities. The centers operated 24 hours per day, 7 days per week, synchronized with shift changes. Mothers arriving for swing shift at 1:45 p.m. could drop children at the center. When they finished at 10 p.m., children would be fed, bathed, ready for pickup. Mothers working graveyard shift could deliver sleeping children at 9:45 p.m. The centers would care for them overnight, feed them breakfast, and have them ready when mothers finished at 6 a.m. The scale was unprecedented. Each center could accommodate 450 children simultaneously. Total capacity exceeded 600 across all 3 shifts as children rotated through. The facilities included nurseries for infants, play areas for toddlers, classrooms for school-age children, medical clinics, and kitchens, producing meals for children and workers. The childcare centers represented Kaiser's recognition that continuous production required supporting infrastructure beyond the shipyards themselves. Workers needed housing near the yards to minimize commute time between shifts. Richmond's population exploded from 20,000 in 1940 to over 100,000 by mid-1943. Vanport City, in Oregon, built specifically for shipyard workers, briefly became Oregon's second-largest city, with over 40,000 residents. Medical facilities had to operate continuously. Kaiser partnered with physician Sidney Garfield to establish the Permanente Health Plan, offering prepaid health care at facilities operating 24 hours. By mid-1943, over 90% of Kaiser Shipyard workers belonged to the health plan. This wasn't altruism, it was production logic. Sick workers couldn't work. Minor injuries had to be treated immediately so workers could return to their shifts. Serious injuries required rapid response to prevent deaths that would demoralize remaining workers. Kaiser treated his workforce as production capital, requiring maintenance and support systems to function optimally. The continuous shift system reached peak efficiency in 1943. By mid-year, Kaiser's 7 shipyards were completing an average of 1 Liberty ship every 8 hours, 3 vessels per day, 1,095 ships per year from a company that hadn't built a single ship before December 1940. The numbers were staggering when compared to traditional shipbuilding. Bethlehem Steel's Sparrows Point Yard, one of America's largest and most established facilities, completed 85 Liberty ships total during the war using conventional 2-shift operations. Kaiser's Richmond Yard No. 2 alone completed 459 Liberty ships using 3-shift continuous operations. The productivity difference wasn't linear, it was exponential. Continuous operation didn't just add 1/3 more production time, it transformed the entire construction process. Ships under construction never cooled completely. Materials flowed continuously without storage delays. Quality inspections happened constantly rather than at shift ends. Workers developed extraordinary proficiency through endless repetition of identical tasks. A day shift welder might weld the same type of seam on the same type of bulkhead, 8 hours per day, 500 times per month, 6,000 times per year. That repetition produced speed and quality impossible for traditionally trained craftsmen who worked on many different ships across varied tasks. The statistical evidence of this transformation appeared in productivity metrics, carefully tracked by the Maritime Commission. In January 1942, Kaiser's yards required an average of 523,000 man-hours to complete a single Liberty ship. By June 1943, this had dropped to 349,000 man-hours, a 33% reduction. Traditional yards showed minimal improvement over the same period. Their man-hours per ship remained essentially constant around 500,000 hours. Kaiser's improvement came not from workers working faster, but from the system becoming more efficient. The continuous operation eliminated countless small delays. Tools stayed organized because they never sat idle long enough to be misplaced. Materials arrived on predictable schedules, synchronized with shift changes. Work sequences became standardized through repetition. Each optimization seemed minor. Collectively, they revolutionized production. The record-setting construction times that captured public attention represented the visible peak of systematic efficiency improvements occurring across thousands of individual operations. The SS, Robert E. Peary, built in 4 days and 15 hours in November 1942, wasn't an anomaly. It was a demonstration of what the system could achieve under optimal conditions. Every procedure, every task, every handoff between shifts had been refined through hundreds of previous ships. The Peary represented the culmination of 18 months of continuous improvement, yet even that record understated the system's true capability. The Peary was a publicity stunt, a morale booster, a propaganda victory. It required concentrating resources, overtime, and coordination beyond normal operations. The real achievement was sustainable production. 3 ships every day, week after week, month after month, year after year. By late 1943, Kaiser's shipyards had completed over 700 Liberty ships. Traditional shipyards across America, using conventional labor practices, had completed approximately 800 ships combined. Kaiser's continuous shift system had effectively doubled American merchant ship production. His 7 yards represented approximately 15% of American shipbuilding capacity by number of facilities, but produced over 40% of total output. The force multiplication from continuous operation exceeded even Kaiser's optimistic predictions. The strategic implications were profound. In 1941, German U-boats sank Allied shipping faster than traditional yards could replace vessels. By mid-1943, Kaiser's production alone exceeded global Allied shipping losses. Admiral Chester Nimitz, commander of the Pacific Fleet, reflected on this transformation in his post-war memoir. Japanese military strategists assumed American industrial capacity, while impressive, was finite. They believed sustained submarine and air attack would eventually sink enough ships to cripple American logistics. They failed to account for continuous operation shipbuilding. By 1944, we were replacing shipping losses faster than Japan could inflict them. We deployed 2 ships for every one they sank. This mathematical advantage, more than tactical brilliance, determined Pacific War outcomes. Industrial capacity operating continuously proved more decisive than any weapons system. The continuous shift system's true innovation wasn't technological, it was organizational. Kaiser demonstrated that seemingly impossible production rates became achievable through systematic coordination of existing capabilities. Traditional shipyards possessed adequate facilities, sufficient workers, of proven designs. They produced slowly because they operated sequentially during limited hours with experienced craftsmen. Kaiser produced rapidly because he operated continuously during all hours with systematically trained workers performing simplified, specialized tasks. The difference wasn't better technology, it was better organization. Yet this achievement came at costs rarely acknowledged in wartime propaganda celebrating production records. Workers in Kaiser's continuous shift system sacrificed years of normal life. They worked constantly, slept irregularly, and had virtually no time for family, recreation, or rest. They did this not once or twice, but for years. The average Kaiser shipyard worker spent over 3 years under this system. 3 years of 8-hour shifts, 7 days per week, rotating through day, swing, and graveyard schedules. 3 years of childcare struggles, sleep deprivation, and social isolation. 3 years surrendered to production necessity. When the war ended in August 1945, Kaiser's continuous operations ceased almost immediately. The Maritime Commission cancelled remaining ship contracts within weeks. Workers were laid off by tens of thousands. The shipyards that had operated around the clock for 4 years went silent. The transformation was jarring. Workers who had spent years in relentless production suddenly found themselves with empty days and uncertain futures. Many struggled with the transition. After years of continuous schedules, normal life felt directionless. Some workers reported feeling purposeless without the constant routine. Others experienced relief so profound they wept. The legacy of Kaiser's continuous shift system extended far beyond the 1,490 ships his yards produced. The organizational principles, the systematic training methods, the continuous operation philosophy, all influenced post-war manufacturing across industries. Japanese and South Korean shipbuilders, studying Kaiser's methods after the war, adopted continuous operation as standard practice. By the 1970s, both nations dominated global shipbuilding using techniques pioneered in Richmond and Portland during the war. American manufacturing more broadly absorbed continuous operation principles. Automobile plants, steel mills, chemical facilities, all adopted 3-shift systems modeled on Kaiser's shipyards. The practice became so common that by the late 20th century, 24/7 operation was standard across heavy industry. Modern supply chain management, with its emphasis on continuous flow and minimal inventory, traces directly to Kaiser's shipbuilding philosophy. Just-in-time manufacturing, developed by Toyota in the 1970s, explicitly referenced Kaiser's methods. The principle that continuous operation with minimal downtime produces maximum efficiency became foundational to modern industrial engineering. The workers' rights movements that emerged after the war confronted continuous operations' human costs. Labor unions successfully fought for mandatory rest periods, premium pay for night shifts, limits on consecutive workdays, and protections against arbitrary scheduling. Modern labor law governing shift work exists largely because Kaiser's wartime system demonstrated the exploitation possible under continuous operation without protections. The childcare infrastructure Kaiser built to support continuous operation vanished after the war. The centers closed, the housing developments emptied. The medical facilities that served night shift workers shut down. It would take decades for American society to build systems supporting working parents comparable to what Kaiser created from necessity in wartime. Modern 24-hour childcare, while still rare, directly descends from Kaiser's Oregon facilities. Kaiser Permanente, the health maintenance organization that evolved from the shipyard medical plan, became one of America's largest healthcare providers. The prepaid healthcare model, pioneered to serve shift workers, influenced American medical practice for generations. By the early 21st century, Kaiser Permanente served over 12 million members. Every one represented an indirect legacy of the continuous shift system that required comprehensive worker support. Henry J. Kaiser never built another ship after 1945. His shipyards closed. His workers dispersed. The continuous operation system that had produced 3 ships daily ceased as abruptly as it had begun. Yet the transformation it represented endured. Before Kaiser, industrial leaders accepted conventional wisdom about production limits: 8-hour days, 5-day weeks, sequential construction, skilled craftsmen. Kaiser demonstrated that conventional wisdom could be wrong. Continuous operation with systematically trained workers performing simplified tasks could exceed traditional methods by orders of magnitude. The SS Robert E. Peary, built in 4 days and 15 hours in November 1942, stood as tangible proof. 3 ships daily for years demonstrated that breakthrough performance required questioning fundamental assumptions about how work should be organized. The human cost of this achievement remains debatable. Workers sacrificed years to production necessity. They worked constantly, slept poorly, saw families rarely, and surrendered normal life to wartime emergency. Some historians argue this exploitation was justified by military necessity. Others contend that no production goal justifies systematic denial of workers' fundamental needs for rest, family time, and human dignity. The debate persists because both perspectives hold truth. Kaiser's continuous shift system was simultaneously a triumph of organizational innovation and a case study in industrial exploitation. It saved lives by producing ships faster than enemies could sink them. It damaged lives by demanding sacrifice beyond reasonable limits. It demonstrated humanity's capacity for extraordinary achievement under pressure. It revealed humanity's willingness to treat people as production inputs rather than individuals with inherent worth. The story of how one civilian's shift system made Kaiser Shipyards launch 3 Liberty ships every day is ultimately a story about trade-offs: production versus humanity, collective needs versus individual rights, victory versus cost. Kaiser resolved these trade-offs decisively in favor of production. His continuous operation system treated workers as resources to be fully utilized. They worked constantly because ships were needed constantly. They sacrificed normal life because normal life didn't win wars. They endured because endurance was required. This philosophy, born from wartime desperation, influenced American industry for decades. The principle that production capacity could be multiplied through organizational innovation rather than technological advancement became foundational to post-war manufacturing. Continuous operation, once considered extreme, became standard practice across industries. By the late 20th century, millions of Americans worked night shifts, swing shifts, rotating schedules that descended directly from Kaiser's wartime experiments. The workers themselves carried contradictory legacies. They achieved extraordinary production through extraordinary sacrifice. They built ships that won wars while surrendering years of normal life. Many remembered their shipyard years with pride. They had contributed to victory. They had proven capabilities they didn't know they possessed. They had earned wages that transformed their families' economic circumstances. Others remembered exhaustion, family disruption, health problems that persisted for decades. Both memories were valid. The experience contained both achievement and cost. The organizational innovations proved more enduring than the ships. Modern manufacturing systems, supply chain management, continuous improvement methodologies all trace lineage to Kaiser's wartime shipyards. The principle that work should flow continuously, that workers should perform specialized tasks repeatedly, that written procedures should replace craft knowledge. These became foundational to industrial engineering. Business schools teach Kaiser's methods as case studies in operational excellence. The human costs tend to receive less emphasis in such curricula. The ships Kaiser's workers built are mostly gone now, scrapped decades ago, or resting on ocean floors. But the organizational revolution they represented endures in every facility, operating around the clock, in every manufacturing system, emphasizing continuous flow, in every training program, teaching specialized skills rapidly, in every manager questioning whether impossible truly means impossible or simply means nobody has figured out how yet. That is Kaiser's legacy, not the ships themselves, but the transformation of what industry believed possible. His workers weren't superhuman. They were ordinary people, achieving extraordinary results because someone organized systems allowing them to work continuously. That lesson, demonstrated in Richmond's shipyards and validated by 1,490 completed vessels, remains relevant wherever industries face challenges. Conventional wisdom claims insurmountable. The continuous shift system proved that human potential, when systematically organized and relentlessly applied, can accomplish what experts declare impossible. The question that haunts this achievement is whether such accomplishment justified its human cost. The ships carried cargo that won wars. The workers who built them carried burdens that shaped lives. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.